pick up. So this is, say this is the right eye. Okay, so let's have, this is the left eye and this is the right eye. Right? So now what happens? Whatever image that falls on the medial or the nasal part of the eye, it crosses over to the temporal field, and whatever falls on the lateral aspect, it crosses like this. Whatever falls here, it will cross medially, and whatever falls here, it will cross laterally. So this is how it initially starts, right? So it crosses the field of vision. Whatever falls on the medial field of vision, it crosses to the temporal side, but when it falls on the temporal side, it crosses medially. After that, the optic nerve is formed and it passes through the optic chiasma. There is crossing over happening with this optic nerve, but here the optic nerve doesn't cross. So this is the optic nerve. This is the optic nerve. This crossing over happens in the optic chiasma. Now this is known as the optic tract. The optic tract reaches the lateral geniculate body or lateral geniculate nucleus. Lateral geniculate body or lateral geniculate nucleus. Stay with me, I will be explaining in detail about it. From here, there will be optic radiations. These are the superior radiations and these are the inferior radiations. They will be entering the occipital lobe, but here, near the occipital lobe, there will be calcarine sulcus, and this is the upper calcarine and this is the lower calcarine. So here, this will be entering into the lower calcarine, but this will be entering into the upper calcarine. That is, the superior radiations will enter into the lower calcarine, but the inferior radiations enter the upper calcarine. So similarly, here we have the superior radiations and these are the inferior radiations, and we have the calcarine. So inferior radiations enter the lower calcarine, whereas superior radiations enter the upper calcarine. So this is how we have, this is the visual pathway. Now let's see what happens when there is a defect. So when there is a defect in the retina, then how does the eye present? See, this is the right and this is the left. So in the right side of the eye, there is a small defect. So that is the scotoma. But whereas the left side is perfectly normal. So this is what happens when there is a defect in the retina like this. But when there is a defect further down, that is in the optic nerve over here, then the entire part of that optic nerve, so say for here the right optic nerve is lost, so therefore the optic is damaged, so therefore there is no vision on the right side. So this is the second lesion, so therefore we don't have any vision on the right side, but the left side is unaffected. Till now it's easy, right? The others are also easy if we understand. Here we have the optic chiasma which is damaged. Even the optic chiasma is damaged here. Say for example, there is a pituitary tumor and it sits and it enlarges and it compresses the optic chiasma. In that case, if you trace over here, this field is lost, right? So this is the right side and this field is lost. Now, and if you trace over here, this field is lost in the left side. So what is this? In both the eyes, the temporal field is lost. So therefore, it is known as bitemporal. But the entire eye is not lost, only half of it is lost. So therefore, bitemporal hemianopia. This loss is known as bitemporal hemianopia. What about the loss in optic tract? When the optic tract is damaged over here, then what happens? If you trace over here, this field of vision is lost, right? So in the right side, this field of vision is lost. So let's have this as 4. And the left side, if you trace over here, this field of vision is lost. So this is called as, so in both the sides, we have the left side being damaged. So this is left, that is, so the left side is being damaged. So therefore we call it as, this is hemianopia, half of the vision lost. When it is lost, then it is hemianopia. But homonymous, that is, it is not a different. So this side right side and that side left side, it's not like that. On both the left side is damaged. So therefore homonymous. But we also call contralateral. Why do we call it as contralateral? Here this is the right side, right? So even though the right optic tract is damaged, we are having the opposite side, the left side on the left visual field being lost. So therefore the right optic tract damage will cause left optic field vision loss. Therefore it is contralateral. We call it as contralateral homonymous hemianopia. This is the term which you need to know. Sometimes it might confuse people. Then what about the other one? Similarly, when the lateral geniculate body is lost, it will be similar to the optic tract. So therefore it will also be presenting with contralateral homonymous hemianopia, because the optic tract is going to empty in it is going to reach the lateral geniculate body, right? So therefore when there is a damage in the lateral geniculate body, it will also be presenting as contralateral homonymous hemianopia. Now what about the defect in the superior radiation? When there is a defect in the superior radiation, in that case, say this, we call this as 6. When there is a defect in the superior radiation, then the superior part is damaged. The superior visual field is lost. And similarly here the superior visual field is lost. How do I tell this? See, the optic tract here is responsible for, when that is damaged, then it is responsible for causing this homonymous hemianopia, contralateral. But here only the superior radiation, the optic tract projects in the lateral geniculate body, and from there we have the radiations. So the radiations are the superior radiations and the inferior radiations, and the superior radiation is responsible for the superior field of vision. So therefore when the superior radiation is lost, the superior field of vision is lost. So here we call it as contralateral homonymous, but it is not hemianopia. It is not half of the vision is not lost, only quarter of the vision is lost. So it is quadrantopia. But which quadrant is lost? Superior quadrantopia. Similarly, when the inferior radiations are lost, we have contralateral homonymous inferior quadrantopia. So how does they have? So they will present with similar to this. Right? So this is how they will be presenting with inferior radiations. Similarly, the superior radiations will enter the lower calcarine sulcus. So when there is a defect in the lower calcarine sulcus, or when the lower calcarine sulcus is undergoing an infarction, then it will be presenting with the symptoms similar to how it will be when there is a superior radiation is damaged. Similarly, when the upper calcarine sulcus is damaged, or when there is an infarction, then it will be presenting similar to how the inferior radiations, when there is damage to the inferior radiation happen. That is a contralateral homonymous inferior quadrantopia. I have only one more thing to say. So here, but when the calcarine, but when both, say for example, this is not for the occipital lobe is supplied by the posterior cerebral artery. When there is a posterior cerebral artery infarction, that is both this is lost, then how will it be? How will it be? It will be presenting as so what is this area that is spared? This area that is spared is macular sparing. That is, they will be having contralateral homonymous hemianopia, but with the macular sparing. Why? This is because the posterior cerebral artery is that which is supplying the occipital. So when the occipital lobe is devoid of the blood, then that part from where the optic radiation